A digital Christmas calendar at the window with a remote control for the guests to open the doors sounds like a mega project. Projections, projector, Arduino and Raspberry Pi do not scare you, then this project is just the right one for you. I've created the digital Christmas calendar during the Christmas season 2022 and I want to show you how I built the whole system. This video is mainly about the technical aspects and all the details in the background, so which components are involved, how do they all work together and which problems have to be solved. I will link the first part of the series at the end and down in the description of this video, and there you can see how the remote control itself was built. I'm happy if you subscribe to the channel if you haven't done so yet, because then you don't miss any of the upcoming videos. And now, welcome to Old School Hunter, glad to have you guys back. To step into the project, let's take a look on how the system is set up. Here at the outside in front of the house we have the control unit with the 24 buttons, which is used by the visitors to open the doors of the Christmas calendar. Yeah, and that's pretty much it for the outside. On the inside, of course, there's a little bit more. So here we have the Raspberry Pi, and I use the Raspberry Pi 4B here, and this one is used as the video player and as the receiver for the signals of the control unit outside. Then we have the projector, which is connected to the Raspberry Pi, and the projector projects the videos onto the window pane, and to make the videos visible I attached a projection material to the window. And in this case I use a simple white sheet of fabric, and I recommend you watching my large test where I tested 12 different kinds of projection materials. And this gives you a pretty good starting point if you dive into the world of digital decoration, and I will provide the link in the corner and of course down in the description. So next to the window on the outside of the window sill we have the Bluetooth speaker, which is connected to the Raspberry Pi using a Bluetooth connection, because the visitors of course will hear some sound when the videos are played. And last but not least we have the router, which is attached to the Raspberry Pi using a network cable, and it also provides a Wi-Fi network to which the control unit on the outside is connected to. So this is the overview of the system and how everything is connected, but how do we play the right video when we press a button on the control unit outside? To answer this question, let's take a closer look at the individual components. The control unit with the 24 buttons is connected to an Arduino Uno R3, and I used a tutorial from the DIYlife.com to connect so many push buttons to a single analog input of an Arduino. Of course you can find the link to this project down in the description of this video. But basically we have a series connection of resistors, and when the push button is pressed, the circuit is closed and the signal is sent to the analog input of the Arduino. The signal is then converted to a value between 0 and 1024. I also connected the Wi-Fi module ESP8266 to the Arduino, and this one provides the Wi-Fi connection. The script of the Arduino basically looks like this. I used the library Wi-Fi ESP and Wi-Fi ESP client to connect to the Wi-Fi and to send the data. And let me show you the setup routine quickly. So we have the initialization of the Wi-Fi module, set up some pins. So we have one pin, so one LED for the Wi-Fi status and one to indicate a button is pressed. And at the end we connect to the Wi-Fi. This is pretty simple, so let me show you quickly. So here we initialize the Wi-Fi module with the SSID, so the name of your network and the mighty password. And then I simply run a loop and try different times to connect to the Wi-Fi, because it may take 1, 2 or 3 times to connect. So I simply run a loop here, and then at the end we have some output for debug reasons. Yeah, and that's pretty much it for the setup. Let's take a loop at the main loop. Here we have the check for the Wi-Fi connection. So if Wi-Fi is available, I turn on the LED, and if not, I switch off the LED. And then we have the magic. Here I read the analog input, and in the result we have the value, and here you see many magic numbers here. And these magic numbers, so we have 18, 40, 55, 62 and so on, were tested out beforehand. So these values may vary when you create such a project. And yeah, I use a large if else statement here to compare the values. And yeah, if the result is smaller than 40, the button 1 was pressed. If it's smaller than 55, button 2 is pressed, and so on for all 24 push buttons here. And let me quickly show you the key press function. Switches on the LED, and then the data is sent to the Raspberry Pi. And the send key function is this one here. Here I use the Wi-Fi ESP client to connect to the Raspberry Pi, and on the Raspberry Pi we have a small web server running. This is something I want to tell you at this point. We take a closer look later on here. Then I created the request here, and here's the URL which is called, and the parameter window key is used to transfer the values, so the pressed button 1 to 24 to the Raspberry Pi. Yeah, and finally the data is sent to the Raspberry Pi here. So if you have suggestions what I can do better in this script here, please tell me about it in the comments. This is the first time I created such a script for an Arduino here, so if you have suggestions, please use the comments. It would be interesting for me. The Christmas calendar itself runs on an HTML website using some JavaScript within a web browser on the Raspberry Pi. I got the scripts from a GitHub project. Many thanks to Timo Fischer Projects at this point who told me about this GitHub project, and I will provide the link down in the description. I adapted the scripts a little bit to meet my needs, but in general it's the same as you can find on GitHub. In short, with the help of these scripts and the website, individual videos can be controlled using the keyboard of your PC, and then the videos are played within the website using the standard HTML5 video player. So all that can be seen of my Christmas calendar are individual video files, and the whole calendar consists of 96 single video files. So you have 24 videos for the Christmas, for the calendar doors, and 72 videos for the waiting sequences and the transitions between each scene. So let's dive into the source code, and I will keep it short. If you're interested, please check out the GitHub project. I only want to show you the key points so you understand how everything works together. So as the first, the whole script acts as a state machine. This is how it's called in the software development. And the first thing we have the key map. So we define the keyboard keys. So I decided to use key 1 to 0 and A to N. Please ignore the key O here, so there's no action 25 at the end. And it says when I press keyboard key 1, please call action 1, 2, call action 2, and so on. And what should be done when an action takes place, this is defined down here. So here we again have action 1 triggers the videos for door 1, action 2 triggers the videos for door 2, and so on. And there's a default case which is used all the time when nothing happens, and this is the first entry here. And this entry simply says, hey, please play the default, the waiting scene. And in my case, this is the calendar itself, and I have an individual video file for each day of my calendar here. So I don't want to bore you any longer with the source code. If you're interested, check out the GitHub project. There's a second JavaScript file which belongs to this project, which contains some logic and the HTML website with the standard HTML5 video player. There's one thing which I added to the scripts here, and this is the date check. So for example, if you have the 5th of December, you can only open the doors 1 to 5, and if you hit the key 6, then a short message is displayed and the door of the calendar remains closed at this point. And how the key press of the Arduino triggers the action within the website, this is something I want to show you in the last component. So that the pushed button sent by the Arduino can trigger an action within the web browser, I use a small web server here. I scripted the web server using some Python script here, and there's one thing I have to admit at this point: I'm not a Python developer, so if you have something which can be done better, please use the comments to tell me about it. But in short, this small web server provides an URL, and you can pass a parameter, which is the number of the push button on the sent by the Arduino, and in short you also can say this web server provides some kind of REST API. So let's go through the script in short here. So first we have some kind of map here, so we have 1, 2, 3 and so on until 24. These are the numbers sent by the Arduino, and these numbers are mapped to keyboard keys here. So we have key 1, 2, 3 and so on until n, and these are the same keys as you saw in the JavaScript file beforehand, and this is why I showed you the JavaScript beforehand. Then I used a cool library called uinput, and this library allows me to send virtual keystrokes to the operation system, and I have to tell this library what keystrokes should be simulated. So we again have 1, 2, 3 and so on until n, and down here we have the part of the web server, and the whole magic lies in this single line here, and I called it virtual keyboard because it is something like that. Hey virtual keyboard, please emit the clicked key to the operation system. And if the web browser is now in the foreground, so you can say it has the focus, it can react to these virtual keystrokes and can play the corresponding video file. So you can say the control unit in front of the house acts as a virtual keyboard for the Raspberry Pi, and this way my visitors can open the door of the Christmas calendar. Cool, isn't it? That was a lot of information, and for some people maybe a lot of technical terms. I hope I could explain it in a way that not only computer scientists understood, but also beginners now know how the whole system works. Admittedly, the interaction between all the individual components is a bit complex here, and it took a while until everything worked together. Nevertheless, if you now don't know what's upside down and you're going crazy in your head, I suggest take a short break, rewind the video and watch it again from the start, step by step. One question you may ask can be, hey, why not using Bluetooth to connect the Arduino and the Raspberry Pi? Short answer at this point, the distance was too long and there was a wall in between. The Bluetooth connection simply was too weak, too unstable and broke down all the time, and that's why I switched to the Wi-Fi connection. Professionals among you might have already seen some points for improvement, so if you want to share it with me, please use the comments and tell me about it. The whole programming of the scripts was deliberately kept very simple at this point, because I wanted to show you the basics how to set up such a project here, and for me it also was some kind of case study to see how to set up such a system. But the point of robustness is definitely something I have to work on for the Christmas season 2023. So we've reached the end of this video, and if you like the look behind the scenes of my digital Christmas calendar, please give me a thumbs up. If you have questions or suggestions, feel free to use the comments. And if you haven't done it yet, support me by subscribing to my channel. This way you don't miss any of the new upcoming videos. Until the next time, feel free to check out all the other videos here on my channel, mainly about the topic of Halloween. For today, I say thanks for watching, and until the next project.